Good morning, my YouTube viewers. In this particular video, we're going to perform a hypothesis test, and it's going to concern masks. And so what we're going to do is we're going to go through the practice question. Is 50% of people wore masks in public? A survey of 600 people shows that 330 people wore masks in public. So you're going to perform a one-tailed right test. The null hypothesis is P is less than or equal to 50%, and the alternate is P is greater than 50%. I can tell you right now that 330 is greater than 50% of 600 people, but we will go ahead and do the hypothesis test. So we're going to write a program in Python to answer this question. And so in order to execute the program, we're going to need to import 3 libraries. So the first library we're going to import is NumPy SNB. NumPy is a numeric library that performs numerical calculations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy.stats as stats. So scipy is Python's scientific library, and stats is the statistical module within scipy. So we're going to import matplotlog.pyplot as PLT, which is the visualization library. So we're going to set our parameters. So the population percent is 50%. The sample size is 600. The sample percent is 0.55, so that's 55%. And your alpha, which is your significance level, is 0.05. Okay, so what we're going to do is we're going to calculate the standard error. Standard error equals np.square root. So it's going to be population percent times 1 minus population percent divided by sample size, and then you're going to square root it. And so that is going to be 0.0204 because I calculated it already. Now we're going to calculate the z-score. So your z-score is your sample percent minus your population percent divided by your standard error, and that's 2.4495. We're going to calculate the p-value for a one-tailed right test. So p-value equals 1 minus stats.norm.cdf. So norm indicates it's a normal distribution, and CDF is your cumulative distribution function of the z-score. So we're going to output the results. You're going to have your z-score, and you're going to have your p-value. So we're going to analyze the p-value. If p-value is less than 0.05, then you're going to reject, then the 0.05 is your alpha. Then you're going to reject the null hypothesis. The sample proportion is significantly higher than the population proportion. If it is greater than the alpha of 0.05, you're going to fail to project the null hypothesis. The sample proportion is not significantly higher than the population proportion. So now what we're going to do is we're going to plot these values onto a curve, a standard normal distribution. So x equals np.linespace brackets -4, 4, 1000. Y equals stats.norm.pdf x. So norm is your normal distribution, and PDF is probability distribution function, or probability density function. Okay, so we're going to plot the standard normal distribution, plt.plot brackets x, y, label equals standard normal distribution, color equals blue. We're going to shade the critical region. Critical value equals stats.norm.pdf brackets 1 minus alpha. So 1 minus alpha is 0.95. And norm is a normal distribution. And PPF is a percentage point function. And PLT dot fill between brackets x, comma, 0, comma, y, comma, where x is greater than or equal to critical value, comma, color equals red, comma, alpha equals 0.5, comma, label equals critical region. So we're going to mark the z-score on the plot, plt.axv line, brackets, z-score, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals z-score. So now we're going to add titles and labels to the graph. The title is One-Tailed Right Z-Test. The X label is z-score, and the Y label is probability density. So we're going to show it. So you've got your standard error of 0.0204. You've got your z-score of 2.4495. You've got your p-value of 0.0072. So the p-value is less than the alpha of 0.05. So that means you reject the null hypothesis. The sample proportion is significantly higher than the population proportion. And then so this is the chart that we've made so you can visualize it. The blue line is your normal distribution, the red is your critical region, and the green is your z-score. So you can see that the green falls within the critical region of the normal distribution. So that means that the null hypothesis is rejected in favor of the alternate hypothesis. But we already knew that at the beginning when we conducted the test, because the question said that 330 people preferred tea over coffee, and 330 is higher than 50%. So we already knew that it was going to be higher than 50%. And so there was a significantly higher than the population proportion. So the next video we're going to make is going to be on lunches. So this concludes our video for this one. And I hope that you decide to watch the next one.